Hello, everybody. Hope everyone is well and making it through this tough time. I know keeping up with the work lately probably hasn't been easy for you, and it's been a real challenge, and I appreciate everyone that's doing their best. We're going to try something different for the next couple classes. We're going to be working with some videos and a question sheet that has a few simple questions for each type of mechanism we're going to go over. And we'll kind of work you through it. You can watch the video and then answer the questions and turn them in. We're only going to do 3 mechanisms a class, so it shouldn't be that difficult. The first few are pretty easy and some things we've been working with as we've been over the last few classes. So hopefully you have a good understanding already of what you're going to see. The first gear train is what we're going to call Simple Gear Train A. And if you look in the packet, you'll see Simple Gear Train A has a picture of the mechanism, and there's 4 questions underneath. The first question is, in Gear Train A, is the speed increased, decreased, or constant? So when we look at the gear and the way they turn, remember the handle, when my hand is moving, is our input gear. And obviously the other one is the output gear. Is the output gear moving faster than the input gear? Is the speed the same, or is the speed going down? Both gears have 60 teeth, so you should be able to understand from what we've talked about ratio what's happening with that. Now, one of the other things we've talked about too is torque. The second question in Gear Train A is torque, which is the power, increased, decreased, or constant. And I want you to think back to what we talked about before we started to do some of the learning from home about speed and torque or power in a mechanism. When speed goes up, what happens to torque? And when torque goes up, what happens to speed? The next question goes back to gear ratio and some of the things you guys have been doing over the last few classes. It says, what's the gear ratio of Gear Train A? And remember, there's a 60-tooth input and a 60-tooth output. The last question, do the gears move in the same or opposite directions? You can see, once again, when I turn this, how they're moving. Are they turning the same way, or are they going in 2 opposite ways? Are they both going clockwise? Are they both going counterclockwise? Or is one going counterclockwise and one going clockwise? All right, that's our first mechanism. The second mechanism we're going to go over is very similar. We call this Gear Train B. And Gear Train B is basically the same, but it has a smaller output gear. Once again, the input gear is the one with the crank or the handle, the one I'm turning, which is the larger gear. And you have the same questions for Gear Train B. In Gear Train B, is the speed increased, decreased, or constant? When we look at this, if we think about how many times the big one goes around, the big gear, as opposed to how many times the little one goes around, you'll be able to know or tell if speed is increased, decreased, or constant. The second one in Gear Train B is torque increased, decreased, or constant. Now remember what we talked about before. When speed goes up, what happens to torque? And when torque goes up, or when torque is increased, what happens to speed? The next one, what's the gear ratio of Gear Train B? Now when we look at this, we have 2 different size gears. The small gear has 36 tooth on it. The big gear has 60 teeth on it. So when we start to talk, we go through gear ratio, how are we going to calculate that? All right. Remember, the 60 tooth is the input, The 36 tooth is the output gear. How does that factor into your gear ratio formula? If you don't remember, go back to the last few classes and you can look that up. The last one, do the gears move in the same or opposite direction? Just like we talked about a few seconds ago. What's happening with those? Are they both moving clockwise? Are they one moving counterclockwise? There's one moving clockwise, one moving counterclockwise. You can put your answer down there. We have one more mechanism we're going to go over. And that mechanism is a gear train, but this time it's a simple gear train with an idler gear. Okay, so now when we look at this, our input gear is once again a 60-tooth gear. Our output gear is a 60-tooth gear. And this little gear is what we call the idler gear. This isn't an input or output gear. Because it doesn't turn, it's not going to be turning another shaft. Like the output gear would if we were using this for a purpose other than learning about gears. So the first question asks you to describe the position. Remember, the input gear has the handle or the crank. That's your start, and then you can kind of put the other parts in to that answer. Is the speed increased, decreased, or constant? So once again, when we're going to go through this, we want to know the speed of the input compared to the speed of the output. These are the two gears we want, because remember, if we were talking about a bicycle and it had this kind of crazy gear train right here, this would be the one the pedal's on. This would be the one attached to the back tire. So input, output. The idler gear is not an input or output. It's just there to turn the gears. So once again, is speed increased, decreased, or constant? The next question is torque increased, decreased, or constant? What I want you to think about with this is if you look at your answer for speed, remember what we say about speed. If speed increases, what happens to torque? If torque increases, what happens to speed? And if there's no increase or decrease, that's what we would consider constant. So use that to answer that question. Next, what's the gear ratio? Once again, we have a 60-tooth input. The idler gear doesn't come into play because it's not an output, and this is our output. So 60-tooth, 60-tooth. You're going to calculate gear ratio the same way. I don't even want you to think about the idler gear. The next question, what's the direction of travel between the input and output gears? Let's take a look at that. Are those input and output gears going in the same direction? Or are they going in different directions? Once again, input, output. And the last one, predict what the direction of travel would be between the input and output gears if the idler gear is eliminated from the mechanism. So if we got rid of this gear, use your imagination here, and these two gears came together, what would happen to the direction of travel? All right, so this is the first of 12 different mechanisms we're going to go through all together. Do your best to answer those questions. And remember, we're doing this, we're learning about this because we're going to build up eventually to creating a mechanical pull toy in class. And this is the knowledge that's going to help you along. Hope everybody has a good day. Keep working hard, and hopefully we'll see you soon.